Hello, ladies and gentlemen. My talk will be in English. Thank you very much for giving me the opportunity to present some of our ideas that we had during our work in northern Fuerteventura. The first picture you see already, the paradigm that we all follow now, let me say, some 50 years. That means that we have grading materials. In this case it is sand, it could be löss, and then we have other colors like this one. And we always interpret this then soils. That means we have soils, we have löss, or we have soils, we have sand. These are sand sheets, paleo dunes. And we always attributed this feature to change, to climate change. The best is from glacial to interglacial, or from stadial to interstadial, but it was always contributed to climate change when we had a soil in between sand dune systems or in löss systems. Okay, we have to doubt this a little bit, and this is why it is called dune parasoil. We can talk about this later. Okay, we go to Fuerteventura. This is off the coast of Africa. Africa, very dry lands here. This plays a role as well. And then we are on the northern part of Fuerteventura, and we worked out these sand fields here, this, and they are interrupted, and this one, and these. And they are interrupted by lava flows, as you see. And this makes it a little bit difficult to do a good stratigraphy, but finally we could work it out by other methods. This is a new sand sheet here. It's not in our focus. Okay, so we have very good access to everything. You see already here these paleo surfaces, the sand sheets in it, some volcano here. When we go a little bit closer, we see already what happened here. We have these sandy materials. They are interrupted by some other phases. Then we have these blackish colors here, and then we have the reddish color. Probably you see it. That means what do we have in total in this area, and what do we have to think about? So first of all, we have the sensors. The sensors is, as you see here, we have these. This is a bathymetric map, and you see the shelf area here. You have a big shelf area, you have a good shelf area here in this part, some here and here. And when we have a shelf area, we have the sandy material. This is the sandy material here, 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 and here. That means to look after a sandy material on the coast in this area is not possible because we do not have any sandy material here. That means that we are very confident that the wind came from the northern direction, northeastern direction, like the trade winds today. So wind comes to, or sand comes to the eastern Canary Island by trade winds from the northern direction. And we have the volcanoes and the lapillis, and these volcano material may cover even these sand sheets. In this case by lapilli deposits, but normally these lapillis and the tephra is mixed into the sandy material, like you see it here in this case. Okay, so the next thing is the dust. We have also dust in this area, and the dust is coming from of Africa. These are the southern part of the Atlas Mountains, and this comes by also by the trade winds and in a very low level. This is this kind of wind, and then we have another kind of wind. It is the high level, the Saharan air layer coming from the sub-Saharan countries, bringing normally the dust to the Caribbean islands and so on. Moose studied this. But when we have a blocking situation over the Atlantic, then we have a deflection, and the dust is coming in a very high altitude. In this picture you see coming back to the island. So this is what we have. The accumulation rate is about 30 centimeters in 10,000 years. It's calculated by Menendez et al., assuming data from today. But 30 centimeters in 10,000 years is quite good for us. Okay, so and what about soil formation? Because we always thought soil formation must be the key. But as we saw soil formation in very, very different situations, so we were not able to combine or to combine the soil formation to climate change. So we ask, what can we do in soil formation intensities in these different colors to explain the different intensities in soil formation? So just take the function of intensity from physics, and as you see here in this little picture, that we have the same energy, and we bring the same energy during the same time span on different accumulation rates, on a higher accumulation rate in the same time and on a lower, and we have this result. So you can play this little game also in changing the exposure time. No, will come out the same. So what we want to say is we can have different intensities of soil without having any climate change. Must not be due to climate change. But the problem is, do we have indeed soil formation in between? Okay, so just to sum up the first part here, we have these dust source, we have the shelf, bringing the sand. The sand is biogenetic, about 80 or 90% of calcium carbonate, and then we have the volcano input. And these are the materials that we have to cope with. And it is quite difficult because they are so highly eroded, so highly relocated, and we always thought that we have soil formation and then soil sediment in it, but the soil formation, we thought it happened sur place, also autochthonous. Okay, so what we see here, this is the chaotic situation. You see in this part the different dipping angles, 3 minutes, yeah, okay, different dipping angles of the material, and our first aim was to combine these in a robust stratigraphy. That was, we were able to do it, and we were able also to date these material a little bit. So roughly about 25 IRSL dating, it is roughly about 5E and 9E when all this happened here in this part. But we could even combine these sand sheets and the sand fields to a robust stratigraphy. Okay, however, it is not precise enough to go to interglacial times, because interglacial is 10,000 years. We cannot, the resolution, time resolution is not good enough. And we did this also with Hans von Suchodolets on Lanzarote. It never worked. Okay, what about changing materials in the profile? This is an issue that must be addressed. So what we saw, that we have many causes to bring sand on the island. It is not only wind climate, it is a deep sea level. This is another climate issue of global extent. And we have many causes of dust supply, for example. Yeah? So that means if we have many causes for one feature, so analogy is a little bit difficult to do. So this was our real problem. Just an example for the sand availability. We know the dating of these volcanoes, and these volcanoes bring lava to all the northern part of the island immediately. That means at about 130,000 years, 130,000 years, yeah, that's it. There was no more sand available, yeah, and we had really difficulties to see more sand in our systems. I have to go through very quickly. Oh yes. Now some geochemical information. We have the dust here, which is important that we have a lot of CAM, clay aggregate minerals. We have the dust imprint into the material, and then we have the sand. But this is a mixture of sand and dust. And sand and dust, this mixture brings coated root cells and abundance of mollusks. But what we do not see is any leaching of calcium carbonate. It means there was no evidence for any soil formation. So we have to change our model here a little bit. That means soil formation is going away and the material comes from Africa. The silt is coming, quartz is coming from Africa, and the clay aggregate minerals, and even the reddish color, because this is the iron, ditionate iron, that means iron of the soils. Okay, I have to go quick through it. Take away. Red layers separating dune and sand units on Fuerteventura consists of red dust. Dust has a higher water retention capacity than sand and thus favors better living conditions. You see the snails with the brood cells, and pretends soil formation, and even may initiate weak soil formation. Environmental change is not always a matter of climate, it's okay. The concept of dune paleosoil sequences on the eastern Canary Islands, indicating glacial interglacial shifts or stable interstadial shifts, is not longer valid because no strong soil formation happened. So we propose the term parasoil. We are not very happy with it, so alternatives are very welcome. Thank you very much.
Thank you.
You may ask your question also in French. I understand French a little bit and I speak a little bit.
D'accord, alors nous avons le temps pour une ou deux questions, en français ou en anglais.
Hello. So you mentioned this source of iron oxide or coming from the Sahara, and today is there such kind of deposition in Canary Islands?
Yes, we normally date it. You have to imagine, we have normally the sand supply, but during sand supply we have also dust supply. But when the sand stops or sees down, yeah, then we have more dust supply, dominant dust supply. So we normally took material from the dust because there we had the opportunity to have the quartz. We first went on quartz for dating, and then we have the feldspars also. It is a little bit a matter of what we date, because in the uppermost part the feldspars must come also from the African island, as far as we.
So if you have a stratigraphy of those deposits at different locations, how would you say that there is no climate change if you find in different environments the same stratigraphy showing this source and enhancement in such Saharan microdust deposition in those islands? How can you fit your model with the real system?
Thank you very much. It's very important. We do not want to exclude it. We had globally climate change, for example, to drop the sea level, but the climate change does not happen too much on this island. We have from the last glacial maximum to the situation of today about 4 or 5 Kelvin. That means it's not a big difference. And we had weather situation normally indicating more humid conditions. But we cannot attribute this to the red color or to these so-called soils. They are not there, but they are good. When we have dust and when we have rain, then the dust will keep the rain, and then the vegetation will come and there will be some snails. But when you have pedogenetic features, I have some even laminar thin sections. Yeah. It's almost nothing, you know. So we did our stratigraphy and we were quite confident by mollusk analysis, and this works very, very well because we have mollusk assemblages that exist only in a certain time span, and then there was a change, whatever it was, and then it disappeared, and then we have other other assemblages.
I have a question. You have exactly the same thing or the same question about the sequences in the Rhone Valley. Mathieu Bosc has shown already. Yes, and here in the sequences we have an alternation between red levels and yellow loss, thick yellow loss units. And our hypothesis is that yellow loss correspond to local sources, and the red levels probably correspond to inputs from the Sahara, but they obviously indicate that the local sources were not providing much material at that time. So they probably, in our opinion, we think that the factor that lowered the local inputs is climate and the development of vegetation with the stabilization of the nearscape landscapes. While at the same time, the Saharan inputs were still coming. And so climate could be behind all this, much of this kind of alternation between red and local and
as we are on a volcanic sources. As we are on a volcanic island, there we have a lot of volcanic activity, and this was in our case. It could be one of the main factors to interrupt the pathway of the sand. This is our. We are thinking about this very much so. But I will come to your talk probably in the cafe pause, because it was very interesting for me to speak with you about this issue. Red layers. Okay. Thank you very much.
Yeah.